The person who measured the speed of light in 1845 was definitely a genius. He was the French physicist Fizeau. Today we will take a look at how he did it. This is the key component of the experiment, a special gear in which every tooth and every gap is the same width. Then you need to set up a light source, which can be a light bulb or a candle, as long as it can emit a beam of light. Next, place a semi-reflective mirror in front of the light. This kind of mirror can let part of the light pass through and also reflect part of the light. Here you need to tilt the semi-reflective mirror slightly. Finally, place a regular mirror opposite the gear, and now you can start experimenting. When we turn on the light source, the light will first pass through the half-reflecting mirror, and then pass through the gap in the wheel to reach the opposite mirror. The mirror on the opposite side will reflect the light back, pass through the gap of the wheel again, and finally be reflected by the half-reflecting mirror into our eyes, so that we can see the light. But if we let the wheel rotate, you will find that the light you see will continue to flicker. This is because when the wheel rotates, sometimes the convex teeth will block the light, and sometimes the gaps will let the light pass. What if we made the gears spin faster? You will find that there is a moment when no light can be seen. It turns out that when the gear rotates fast enough, the light will be completely blocked by the convex teeth on the gear as it passes back and forth through the gear. That is to say, when the light is emitted from the right, it can reach the mirror on the left through the gap, but when it returns from the left, it happens to hit the convex teeth, so that we cannot see any light. Note that this phenomenon is actually the key used by Fizeau to measure the speed of light. Knowing the speed at which the gear rotates and the distance from the gear to the mirror, you can use a simple formula to calculate the speed of light. According to speed equals distance divided by time, the distance is twice the distance between the gear and the mirror, and time is the time it takes for the gear to rotate one gap. The gear used by Fizeau has 720 teeth and 720 gaps, and it rotates 13 times per second. At this time, it is easy to find that the time it takes for the gear to rotate one gap is 1/18720 seconds. The distance from the gear to the mirror is 8 kilometers, so a round trip is 16,000 meters. Then adding the formula, you can calculate the speed of light to be 299,520 kilometers per second, which is very close to the speed of light we know now. It is hard to imagine that more than 170 years ago, Fizeau was able to measure the speed of light with such a simple experiment. It is really impressive.